Today we're going to talk about parallel lines a little bit more and how they relate in triangles. Now here's a theorem that you probably maybe learned in middle school, I don't know. The Triangle Sum Theorem, and that says that the sum of the measures in a triangle is always going to equal 180. Did you know that? That if you add up that angle and that angle and that angle, it always will add up to 180 in a triangle? Okay, that's called the Triangle Sum Theorem. It's kind of a big deal. We got a big sticky note. You might want to star this. The Triangle Sum Theorem says the angles add up to 180. Okay, so let's use the Triangle Sum Theorem. It really is a very common thing to come across where you have this triangle and you're trying to find some missing angle measurements. You'll always find this type of a question on an ACT test. Let's look at it. They want us to find the measures of x and y, and it doesn't say z, but we're going to find z anyway. Okay, so here we go. Looking at this, how many triangles do you see in this picture? Okay, I want you to say 3. Did you say 3? Because here's one, this little one, and then there's this little one, but then there's the big one also. So there's 3. I'm sure you said 3. Okay, so let's look at them just piece by piece. I guess I'm going to start with this little triangle here because I already know these two angles. So to find x, which is one of the things they want me to find, well, they have to add up to 180. So I'm just going to type in my calculator. You might want your calculator handy today. 180 minus 43 minus 59. And whatever is left is what angle x is. So I've got angle x figured out to be 78 degrees. Now, if this is 78 degrees, do you figure you could figure this angle out right here? Because what type of angles are those? They're a linear pair, and a linear pair are supplementary. So y would equal whatever 180 minus 78 is. I don't know why I'm typing that in. That's 102. Okay, 102 degrees. And if I know that this one is 102, do you suppose you could figure out z over here? Because again, I'm just looking in this little triangle here. I haven't ever really even used the great big triangle, though I could have. There would be different ways to do this. But I've got my 102 and my 49. If I subtract those from 180, I end up at 29. So then angle z is going to be 29 degrees. Now you could have looked at that differently. You could have looked at it like looking at the big triangle here, and you could have added these two together, so you would have known that angle, and then you had this 59, and then z would have been the missing piece over there. Would have got you the same answer, either way. Okay, the next theorem I have is the exterior angle theorem. And this one says that if you have a triangle, and then you extend one of the sides, and that's what we have going here, this triangle, and then this leg of the triangle gets extended. Well, it creates what we call an exterior angle. Angle 1 here is an exterior angle. And what happens is that this exterior angle, let's see what we've got, the measure of the exterior angle equals the sum of the measures of the two remote interior angles. Okay, this word remote means like far away. So for angle 1, there's 3 interior angles in this triangle. You got this one, and then you got this one here. But this one is adjacent to the one. So that's not the one they're talking about. When they say remote interior, they mean the ones away from that. So they're saying that this angle here is equal to the sum of these two, which kind of should make sense. That we could prove that if we wanted to. Not going to take the time today, but we could, because you got supplementary angles here. You got a linear pair. So you know that this angle plus this one would have to equal 180. But then I also have this angle that happens to be one of the angles in the triangle. And I know that this angle plus these two would have to add up to 180. And so it only makes sense that this would have to be the same measure as those two added up. All right, so that's called the exterior angle theorem. Let's try using it. Here we have a picture kind of very similar to the previous one. I've taken it and I've extended one leg of this triangle to create this exterior angle 1. And remember that the the exterior angle equals the sum of the remote interior. So all I got to do is add the remote interior, and then I would know that the measure of angle 1 is 98 degrees. All right. See if you can do the bottom example here. It's a little bit trickier. Got to think a little bit more. Go ahead and pause the video. Go find the measure of angle 2. All right, here's what you'd end up doing. You'd have to say that the sum of the remote interior, I named it x, so 59 plus x should end up equaling 124. And you can set up a little equation, but you might have just known that, oh, I need those to add up to it, so you can just take 124, and you can subtract the 59 and get your answer. Whether you showed it as an equation or not, you should have gotten 65 degrees on that. All right, so this is our last slide, and we're just going to make this a little bit trickier. So when you look at this, there's angles all over the place, and they ask us 3 questions. They want to know which ones are exterior angles, and then it says name the remote interior angle for each exterior angle, and then how are 6 and 8 related. Okay, I thought I'd just set up a little chart here and see if we can figure out, not all of these are exterior angles. Okay. For example, first of all, I know that angles 1, 2, and 3 are inside my triangle, so those are definitely interior angles. But just because these are all outside doesn't make them all exterior angles. An exterior angle is formed by extending just one of the sides along with one of the legs. So like an example would be angle 5 here. Let's start with angle 5. Because what I have is this is the leg of the triangle, and then this is the other leg that gets extended. That makes 5 an exterior angle. So let's go ahead and write that in our chart. I know that angle 5 is an exterior angle. And then what would be its remote interior angles? Well, I already told you 1, 2, and 3 are the interior angles. The remote ones would be angle 1 and angle 3. Okay, now, there's nothing going on over here at 1, so it's all right down here in this mess as far as figuring out what's going to be an exterior angle. So let's look and see what we've got. If I use this leg right here, and let's pretend it did not get extended. I'm just going to use this leg, and I'm going to say this one extended. Okay, well if I use this leg and extend this side, that's creating angle 8. So angle 8 would be an exterior angle. But what if I went the other way? What if I said, okay, let's just stop this leg right here and extend this leg this way. Okay, and now I'm using this one, and that creates angle 6. 6 is also considered an exterior angle. It's just kind of going wrapping the other way around the triangle. 7 is not, because it's required both of these lines to extend, and we only extend one of them. 4 is not an exterior angle either. It is only using one side. It doesn't even use the other side of the triangle. So they were trying to be sneaky, but all I have is 6 and 8 are my only other 2. So let's go ahead and finish this out. Angle 6, and then what would be your remote interior angles? Angle 1 and angle 2. And how about if it was angle 8? Still angle 1 and angle 2. All right, and then the last question, how are 6 and 8 related? Well, if you look at it, 6 and 8 are actually vertical angles here. And so 6 and 8, how are they related? Well, they're vertical angles, but then that would also make them congruent. They'd be congruent because notice that they're going to equal the sum of 1 and 2. So they both equal the sum of 1 and 2, so they're going to end up being equal to each other. All right, that's all I've got. Go do your homework. Good luck.